Maple syrup is a syrup usually made from the xylem sap of sugar maple, red maple, or black maple trees. Late season sap has less sugar and must be boiled more to concentrate it, resulting in a darker syrup. As the sap boils, water evaporates until pure maple syrup remains. For this experiment, I need a baking pan, pure maple syrup, a saucepan, a large spoon for stirring, a candy thermometer, a GoPro camera, an apple cutter, notebook paper, and a paper cup with 10 pennies.
Step 1.
Grease the baking pan with cooking oil or line it with a sheet of wax paper and place it next to the stove.
Step 2.
Label 5 pieces of paper to say 5 different temperatures and spread them out on the pan.
Step 3.
Heat 1 cup of maple syrup over medium heat in the saucepan.
Step 4.
Thermometer to carefully measure the temperature of the syrup as it heats up.
Step 5.
Bring the syrup to a boil and allow it to cook, stirring frequently.
Step 6.
Once the temperature reaches 230 to 235 degrees Fahrenheit using a metal spoon, quickly pour 1 teaspoon of the heated syrup onto the baking pan.
Step 7. Heat steps 4 and 5 for each of the temperatures, so you have 3 dollops of syrup for each temperature. In total, you should have 15 dollops. Step 8. While you let the samples cool, clean up your workspace and take pictures of the dollops. Step 9. Make your observations and record them in your data table. Ask questions such as, what color is it? Is it transparent? Does it feel sticky or smooth? And does it seem caramelized?
As you can see in this data table, all the samples were a shade of brown and orange. The first 3 were transparent, sticky, and gooey, but the last 2 were not transparent, were hard and smooth, and were caramelized.
Step 10. Make a second data table to quantify the color of the candy samples and label it hue, saturation, and brightness of the maple syrup candies. Step 11. Use the color picker tool to find each of your candy's hue, saturation, and brightness.
You can use this tool to find different shades of a color and find its hue, saturation, and brightness.
Step 12. Record your observations, then find the average hue, saturation, and brightness for each temperature and candy.
This second data table shows the different hue, saturation, and brightnesses of each temperature candy and their averages.
Step 13. There's a lot of steps. Make a third data table to measure the stiffness or consistency of each candy and label it cutter imprints on the maple syrup candies. Step 14. Place a candy on a hard surface and arrange an apple cutter on it so it's sitting on top of the candy. Step 15. Place a paper cup on top of the apple cutter and add 10 pennies to the cup one by one. Step 16. Remove the cup and cutter from the candy and inspect it.
As you can see, the cutter left an imprint on the candy.
Step 17. Candy and record if the cutter left a noticeable impression on the candy. Step 18. Steps 14 through 17 for each temperature candy. Step 19. Number of candies that had an imprint on them for each temperature range and record your results in your data table.
This graph shows that the cutter left an imprint on each of the candies.
Step 20. Gently bend the candy to see if it is flexible, snaps, or crumbles, and record your observations in the first data table.
The first candy is gooey and very soft. The second candy, you can change the shape. The third candy is softer and bends. The fourth candy bends before breaking. and the fifth candy breaks when bent.
Step 21. Gather your 4 taste testers and have them taste each candy. Ask them questions such as, how does it taste? Which was the sweetest? Which texture did they prefer? Step 22. Then record your results.
This graph shows the average hue, saturation, and brightness for each candy. From this experiment, I learned many things about maple syrup and how temperature affects it. I learned that the longer you cook the syrup, or the higher the temperature becomes, the less water is in the syrup and the more sugar concentrate, making the candy harder. This also makes the candy dollops darker. I also learned that the higher the temperature, the more the candy tastes sweet, sugary, and more like maple syrup. The longer the syrup cooked, the harder it became. My hypothesis stated that if I heat the syrup to a higher temperature, then it will be harder, and if I heat the syrup to a lower temperature, then it will be softer. My hypothesis was correct. Syrup goes from clear to brown as its temperature rises. It no longer boils but begins to break down and caramelize. The sugar begins to break down and form many complex compounds that contribute to a richer flavor.
We've gone. Once the temperature reaches 200.
Repeat all.
Go.
Did you say what?
No idea. Okay.
Repeat. No, there's two. Place a paper cup on top of the third data table. I have yogurt in my hair.